Hi all you nice people of the internet and fellow retro enthusiasts. This is another video from Commodore, and we are following up on some of the work that we have not finished off yet. And this is the second part in the series about the Commodore 1802 monitor. And I can already say that there will be another installment in this series. We have done a lot of work on this monitor. We have changed all the capacitors, and I'm also going to take you through a measurement of some of these caps to see if the recapping really was necessary. And we also hit another snag. I will come back to that later. That means that we have to have another follow-up episode. There won't be much technical details in this video, but there will be some. And there might be some tips that you can pick up as we go along. So enjoy the content, and we start by filling out the missing capacitors that we had to order as a second order from Mouser to be able to fill all the holes in the PCB. Hi, we are now back in the shed, and we are going through the rest of the caps for this monitor. And there has been a lot of different versions of capacitor lists and numeration and stuff on this monitor, so I had to go all over it manually again to check that I got the right values in the right place. And we do have some caps here that we missed last time. We've started from the top here. We have the 1000 microfarad here that we had last time, and we have this one down here, 160 volt, 100 microfarad. It's this one, and otherwise I start from the top and just fill in the values as we go along. Yes, I think we have what we need this time. But of course there is no way to be sure until we have found them all and seen that this is the right values. And this one is rather large, 35 volt, 1000 micro, and that is actually C102, and that should fit over here. It's quite a large one. Maybe we have to stretch the leg. We have to see here C308. It's this one. Yeah, but they are able to coexist there just nice. And C103. Just up here in the same neighborhood, like so. And this is C610. 610, where should that be? We can take 704, I see that here. And then it was 610. I do have some 6s here. And this actually was this one where we already had soldered in one. Why is that? Okay, this is a right one, so I probably just marked this before I found that one, so that is okay. So then we have these 5 to solder in here as of now. Just be careful we don't break anything. And now it's time for some soldering here. Do you remember from last time that this PCB does not have a very high quality? The pads are easily lifted from this board. So it's about not applying too much heat, but of course there is the right amount of heat you have to use to not get cold solder joints. That's can look amazing but don't give the proper contact. And then it was this leg of this one. Probably that will be enough to make the rest of the solder job much easier. And the last leg on this capacitor has this jump wire that needs to be soldered to one of the legs, and this is a wire that was there from I desoldered this. So I just keep it close to the leg so I don't short anything. Like so. Take a peek on the other side to see how this looks. Like, it's actually possible to test this without putting it all back together, and if we are a bit flexible, we need to have, so this is the degaussing, so this needs to be something like so to be able to yeah, I do think we can try to mount this like so and see if we can make this work without putting everything back together, because there might be some adjustment we have to do on the inside of things. So I think we will try to do just that. Yeah, I will try to reposition this on the bench so that it will be a better view. And I use this Galo driver to keep this monitor upright. At least we'll be partially able to see what's going on with the camera placed as such, and I will try to cover as little as it's possible of the stuff when I'm actually working here. And this can't be said enough times. The high voltage stuff, if you don't know what you're doing, keep your hands away. Back in the day, my teacher told me that when you are dealing with high voltage stuff on a TV or a monitor, always keep one hand in your back pocket. And I tend to do just that. For the speaker. Or was it really the speaker? Normally when you detach these kind of things, there are plugs that helps you by not fitting anywhere else, but on this particular chassis there was 3 of the 3-pin prongs that you could place almost everywhere, but in the end I did manage to find where they went, but it was not obvious to them. Yeah, the ones that is not doing this on a regular basis. This at least is going in like so. This is from the power switch. And this is the LED from the power switch, and another 3-pin connector that I don't quite know what to do with until I sorted it all out. This probably should go like so. Now I have 3 that's in play, but this is probably right. But then begs the question, which is the loudspeaker and which is this one? Yeah, probably something along the lines of that. But before I test this, I need to be sure that there is no metal or pieces of soldering wire or legs from cut off components and stuff underneath the PCB. So let's do some housekeeping. Yeah, and with everything plugged in, hopefully where they should be. It was a bit confusing with all these wires with 3-prong plugs. But now I'm starting to think that this power switch does not work. It's not making the right noise, I think. So I do think we have a case of a switch that does not stay in contact when it's released, because the monitor seems to start when I push it in and then it stops when I drop the switch. Yeah, I will just unplug the power and I will measure out this plug. As you remember, this was separate leads from both sides of the plug that led to the board. And this was strange. On one side it seems like it is contact. I do seem to remember that this is a 2-pole switch that breaks both lines on the 220 volt range. And on the other side is nothing. This is a first. I've never seen this switch behave like this before. Yeah, and I will also try to measure the same on the switch itself. And it does seem to be exactly like measuring on the plugs. I do think this power switch does look a bit on the cranky side, and that's nothing unusual for these old Commodore monitors with push switches. So I do think I'm going to take that out and have a closer look at it. So I'm just going to unscrew it. It's fastened with 2 plastic tapped screws, and of course it's tied to the other leads that goes into there with a cable tie, so I have to cut that. Okay, what the heck is going on here? There has been someone inside here before, and it seems like one of the lines is soldered shut. So that was why we was measuring continuity on one of the poles. But this needs to be fixed, and sometimes I've been able to fix these switches, but these seems beyond repair. A very strange thing, and I'm going to measure from the plug here. This is of course not the original plug, so this has probably been changed from a Euro plug, and it's also not properly closed, so properly closed. Yeah, so it's coming into that one, and then this one is coming into that one. This switch obviously needs some attention, and I don't know, but the best thing I do for now is just to desolder it and just map the wires together. I guess just as an easy fix this will hold together, but I can't for the bare sake say that this side of the switch should quit working before the other side. So why this is soldered like this, I don't know. Yeah, I will see what I manage to do here, but probably I'm just going to cut the wires and just solder them together when I do other tests, and I have to see if I can find a switch that fits into these. I'm not sure if it's the same switch that fits some other Commodore monitors, then I might have it. And these are the ones that should be just tied together, like so. And I didn't notice that the camera was running out of battery, so I lost some minutes of footage here. And I just have to dismantle this further. Take a close up of these. This bracket is fastened the same as these leads, and it's just plastic tapped screws, a bit smaller than what we have on the other places. And this is the counterparts for this. These are tapped with melted plastic, so it is possible to split this switch somehow, but if that gives us useful access and that if we can put it back together, that I don't know. And I need to tape up these before we can try anything. And please don't look too closely at this. This is entirely the wrong tape to use. This is used for marking ground wires, at least in Norway and I think the rest of Europe. These certainly are no ground wires. This monitor is not switched on the ground level. It's permanently attached to ground, as you can see down here. And it's the same that goes back here. This is also a ground wire. But no, this is insulated. We have removed the switch. I do need to take this apart to see if there... Yeah, because this does not come all together, so I need to see if there is something wrong inside here. Just another yellow screwdriver. And let's see here what's wrong. I do wonder if it's that this is bent that causes this to happen, because this should be okay. Yeah, I do think it is, because this is slightly bent, and I do wonder if this should be maybe a bit more like so. This also had to be addressed, but I'm not bothering with that now because this needs to be inside the end. And I do need to verify a video source that we can connect until we have something more sufficient to try. And we also need to put the switches for the source and stuff in the right positions. Yeah, I might just use my my C64 as the video source. I'm just going to find some cables to hook this up. And I do have a video on my C64, and I'm not sure how I'm going to hook this to make sure that everything is stuck together, but maybe like this. And this needs to be connected to video like so. And then I need to find somewhere to plug in this. No explosion at least, but no picture either. I will just disconnect this and find a mirror that I can have in front of this, so I see the picture from the front. Yeah, so then let's try to plug it in again and see if we can find something. I've placed a mirror here, and it's actually my daughter's extra bathroom mirror, and it's pink and everything. And we do have a picture now, so it was the input selector, it seems. Very sorry for the poor picture quality in the screen recordings. I was not planning to do this clip, so this was the best I could do with my phone just now. I didn't expect this to work quite so easy. But there is a real big instability in the picture, and it might be due to some other potentiometers that we have adjusted. It also can be due to a difference in the capacitor values. So to get this working, I can't seem to find that any of the normal adjustment screws will do. So I do think we have to do something, and I do think it's the horizontal hold that does not stay within range here. So I will try to find a screwdriver to adjust that. Yeah, I just use this metallic screwdriver. It's not the best, but it will do. And we can see immediately that this makes a difference. With a little tweaking to and from, I get this picture to stay straight in the middle and to be stable, I think. So that is something we can call a result. And the picture have nice colors and stuff. And by the way, all this turning of these potentiometers is just to keep them clean, because I have lubricated them. Yeah, I'm going to adjust this to the frequency of is the frequency, 10 kilohertz, 100 kilohertz, 100 hertz. So I think I take all these capacitors on 100 hertz. And this is the big one, 150 microfarad, 400 volt. And it actually measures quite good in both. Yeah, let's see. And I take it back to 100 hertz. And I measure now with the ISR, and it's 0.4 ohms, and that's quite good. Let's take another one. This is 100 microfarad, 160 volts, and it also measures quite good. I don't have any experience from before with Daewoo capacitors. I've probably seen them only in Daewoo things. So, and this is another 100, 160, and it measures even better than the last one. This one is 1000 micro, 25 volt. And it also measures quite good. You have to remember these capacitors is at least 20% off, and 1000 micro that measures 908 by 100 hertz and 0.1 ohm ESR, that's quite low. And this one is about the same. It's exactly the same. Yeah, it measures a bit lower, but even lower ESR. This one is also 1000 micro, but 16 volt. Also measures good. And here you have a 10 micro, 160 volt. This measures 5 ohms. Put this aside and see what the other caps about similar size measures. But this is low capacitance and their high voltage, so they normally have a bit of ESR, and 5 ohms seems to be the norm here. So I do think that is what they are supposed to be. This is 220 micro and 35 volts, so this probably has a bit lower ESR. Yeah, 0.4 ohm. This is a good capacitor. What was this? This was 470 micro and 35 volts. And this looked to be a bit suspicious. And you can see that is 4 picofarads. So this actually was bad. And here you can see this glue here is mixed with some other stuff. It's not the same color as this. So this one actually has been leaking and is bad. You can also see that this has corrosion on top. And this was the one that I saw in the picture and suspected was bad. Yeah, 440, and this is 470. This is totally okay. This was, I can't read this without my glasses. Yeah, this was the same, 470 and 35 volts, and it measured okay, I think. I measure it again because I can't remember. Yes. 470 and 16 volts. So this can be a bit higher ESR, but lower ESR I mean. Yes, it's okay. 100 micro. Yeah, this is also okay. 35 volt capacitor. This is 417 and 16 volt again. Yeah, it's okay. 100 micro, 25 volt, and it's okay. And this was 2.2 micro. This is 32.6 ohms. I find that to be a bit on the high side. We can see if I find some similar ones. This is 1 micro, 160 volt. 160 volt, they tend to be high ESR. Yeah, and this measures quite okay. We have 100 micro, 16 volt again. Yeah, measures just fine. 10 micro, yeah, 17.8 ohms. That's probably how it should be. 4.7 and 16 volts. Wasn't it 4.7? Was it 47? Yeah, it was 47. So this is also okay. And this one is 47 as well. So it should measure about the same. Yeah, it's okay. 1 micro, 50 volts. Yeah, and that's okay. And this was getting kind of repetitive, so just fast forward till we are finished. Yeah, and this was the last one, and this is a 22 micro, and it's 16 volts, and it measured just fine. Some of the 1 microfarad capacitors measured a bit high, and this is totally okay with 32 ohms. It's a 2.2 with 160 volt. But I did measure a bit of variation on the 10 microfarad caps. Otherwise, it's just this that actually was bad. So, does this confirm my theory that the caps from the 80s have a bad reputation and you don't need to recap your old equipment? Yes, I do think so, because I think most of these capacitors would last 20 more years without issues at all. But I have replaced these with high quality capacitors, so the capacitors that I've replaced them with now will probably last for 30 years. So we might have bought this monitor 10 more years, but then again, other things like the picture tube and other stuff might break before these caps would have gone the way of the dodo. So I do think that I will continue to recommend to not do a full recap if you don't have to. And I could have changed just this capacitor and probably the monitor would have worked just fine. But I'm not going to put these back in to confirm that. But I will give all these capacitors back to the owner and he can have them as if someone want to make this monitor 100% original again at a later time. They have the option to do that. Yeah, as you was seeing through the testing of the capacitors, you might notice that a lot of the capacitors was waiting in on the low side of capacity, and that is also my experience from before, that when you measure on old capacitors, they have lost some of their capacity. And should you replace them because of that? Probably not, because it depends really on what kind of circuit they are in, and electrolytic capacitors are seldom used in circuits where their capacity is described as an exact value, because these components often have a very wide variety in their specification. But as I was finishing up this video, I just saw that the YouTuber Tech Tangents released a video about reforming capacitors, and let's hear what you have to say.
Hello there. This video covers the technical information, process, necessity, and results of reforming capacitors. Put simply, this is a procedure that takes capacitors of an unknown health and reconditions them to potentially be usable again. This has by far been the most controversial topic I've mentioned in any video.
Yeah, I will advise you to watch this whole video. Just a shortcut. Do I agree with what he says? Not necessarily, because he jumps over one important step, and that is, yes, the deoxidation and thinning of the oxide layer on capacitors are actually quite a big deal. But today, this is a process that is lesser than it was back in the days because of improvements to the electrolytic compound. And also, do we have any control over this process? The thickness of the oxide layer is the insulation in the capacitor, as he clearly states, and that's totally true. And that means that the capacitors that's made for 10 microfarad, if you want a higher voltage component, you can actually do some reforming yourself, and you can increase the oxide layer, and by that you can also increase the voltage that the capacitor can take. But it comes with a price. And that you can hear Tech Tangent's own words about. So let's hear what he has to say about the ESR ratings.
If the capacitors don't show any visible signs of failure, they are likely worth trying to reform based on the risk assessments that I mentioned earlier. But this still doesn't mean they will be good. The capacitor I fully reformed at 50 volts I personally think may have a higher ESR than normal, since it seems like it's a little slow to respond. It's also a bit difficult to measure ESR with something like this on higher capacitance parts like this. So I would recommend for any caps that you would attempt reforming that you connect an oscilloscope to the voltage rail after reassembly to look at the ripple current on it and check if it's getting hot.
Yes, and this is really the big problem with this. Because if you do this in a capacitor that stands in a modern circuit, a switch mode, the ESR rating is kind of important, because it is, it's the easiest way to describe the ESR is, this is the DC equivalent of the resistance in a circuit if you apply DC voltage across it. And if you apply a high current through a capacitor like this, it will get warm, and a warm capacitor will make its, what should I say, it break down faster, and it might even boil, and that's what's causing the 19's capacitor plague when the top of the capacitor is popping off. That is because they are heating up internally, and higher ESR will do that for you. So if you use this capacitor to, as he says, dampen ripple, the capacitor will get warm and it will pop eventually or dry out. As we have no way of knowing how fast this deforms, I've seen other web pages see that if you put something on the shelf from 6 to 18 months, you should reform it before you use it. And that actually was the advice back in the day. You can take any device and just power it up to a triac so that you can get a very slow warm-up of the components, but that in itself is not the same as reforming the capacitor, because that is a process that one power-up or a slow power-up is just half the step needed to reform a capacitor. But of course you can get some form of rebuilding. And he also states some other thing in this video that simply is not true in most cases, and that he says that analog regulated power supplies or regulated power supplies can't be reformed like this, and all the most common ways of regulating power that is not a switch mode, you actually get a lower voltage until the voltage stabilizes. So you can actually do this with almost any device that has transformer in front of the capacitors. There you can actually do this and not make something pop. But in my experience, things has been laying for many years. You power it up and it kind of works. All the equipment that we use in computers and stuff is very low voltage. Most of the things that we encounter on main boards and stuff is 12 volt or 5 volt. You have some old computers that has plasma screens and other stuff where you have 160, 200 volt on stuff, but that's not very common. And you also have some other kinds of high voltage stuff out there. But in most cases we treat things as 5 to 10 to 12 volt. I don't think these capacitors decrease in a way that will eventually make these go pop, because I think the process has gone too far if you are able to reprocess a capacitor that should stand these low voltages, and don't do that. Yeah, that was a bit of rambling here in the end. I advise you to watch Tech Tangent's whole video and maybe leave a comment, either on his side or my side, what you think about that. The technique he describes is totally right. It is in accordance to the datasheets of the manufacturers, but if this is a wise thing to do, that's the question. But anyway, this video has been far longer than I anticipated. We have a working 1802 monitor. We only need to wait for the switch. Hopefully I will get that in a week or two and I can reassemble this monitor and give it back to the owner. Hope you enjoyed the content. Please hit like and subscribe as it will really help out the channel. I have this goal about reaching 1,000 subscribers until the summer and the time is really running out. So, thanks for watching. See you in the next one.